So to get this off is going in this tab. 1. This tab. 2. And come over to a third one. And it's already almost off. You just got to get a fourth one to come loose. Let's go fourth one over here. Come on, buddy. You're not going to be able to turn it because there's a line in there. Okay, so we got to get the fifth one. Of course, it's behind this stuff over here. Come on, buddy. All right, there we go. That's coming off. As of right now my car is saying, I put this back on after screwing with it. My car is saying that there's a dead short, which is what I saw when I try to apply it. There's a dead short. I mean, I don't know if I burned the coil when I first tried it with a lower voltage or what. And also when I went to go take it off again, this had snapped open, so I had not put this all together good. Let's see if I can open this on camera. All right, so you're gonna want to mark it. So I marked it where it came off of. I also took a picture. So your vacuum coming in here, so it's over there, and you're just gonna line this one up. Don't jam anything in here because that's that very delicate diaphragm is in there. I was saying I put a screwdriver in there to hold it open because when you go to do some more of these, it has a tendency to snap back on the opposite side. Actually, that's not how I did it. I was doing it this way. Sticking it into these tabs like this. And when you kind of do it that way, it makes the opposite side come back on. Oh yeah, there's your marker. That makes sure you put it on correctly. So I guess you don't have to physically. And here's another marker. Get it perfect. All right, this one is still connected. All right, there we go. Remember, don't do what I just did, prying that. I'm only doing that because I'm on camera. Don't do that because you're gonna screw up this. This is very delicate. And you just need to get one more to pop and this thing will be apart. Okay, like that. I'm only taking this apart because I want to see if I can get this out, and I think I have to pull these out. I think that's what's actually holding it in. I think that prong and that prong, I think that's what's holding this in. I don't think it's this metal part. I think those are actually what's holding it in. It looks like because they're split, there's probably a wire going down, and when you push them in there, they pinch the wire. That's my guess. So I want to see if I can pull those out. I have another one coming. All right. So you're supposed to be sucking on this. When I suck on that, it sucks air from here. If I cover this hole, it starts sucking air from there. And give it a listen. So that kind of seems to be working, although I think my valve is stuck. That's inside of here. I think it's stuck. And again, applying any fluid to any of these isn't going to do anything, especially putting fluid into here. That's not going to do anything except fill this cavity up, because this is your stopper right there, and that's a little piece of rubber. That's not going to get dirty. There's nothing in there. It's the solenoid. This is trying to decide if your vacuum is going to go to here or to here. And this is the portion that's jammed and needs to be unjammed, but I don't see any way to open this. None at all. And when I'm telling you, when I apply a voltage to that, it's just a dead short and starts to melt the wires. So anyway, I see how this thing is put together. These posts go in through here, and you see how they're split right there? That's because these posts are put through. They're jammed in through here, and then those are probably split because they're connecting to a piece of wire in there. They're splicing to a piece of wire. So you probably pull those out, and then this piece comes right out. But it looks like you gotta loosen this metal piece, which is also holding it in. That, and then pull these two posts out, and then this whole cylinder will come out. Alright, so I was actually able to pull these out. As you see, they're serrated. They're serrated on this end. I don't know if that's focusing. See, they're serrated. So when you stick them in, it catches the plastic and they can't be pulled out. I was able to pull them out, and then of course, after pulling them out, I noticed that this is a sticker covering a screw. So, covering a screw, the Torx. So let's see what size that is. Alright, so that screw is a Torx 10. I knew there had to be something else holding that thing in there. Alright. I have to find something to pull that with. Okay, this screw doesn't do anything. Yeah, it doesn't do anything. This screw only screws into the plastic, so I'm not sure what that does. So anyway, to get this out, what's holding this actually in is these teeth. This is in like this, and they're like this. This is on the bottom. This is on the bottom down there, covering up that hole. So that screw is only screwed into the plastic. This is on top of this, like this. You have a rubber O-ring right here that seals down into that hole down there. It's sealing to seal off the path through here and isolating the air to here. I'm not exactly sure what the point of that screw is. Maybe that's something to do with how this is made. Or maybe it adjusts the height of this, how far up this thing is up into there. Because you could see the screw hits that in there. Maybe it adjusts how far up this is. Oh, actually, this is like this, huh? This was like this, sorry. Yeah, so maybe that screw lets you adjust the tension of this. Sorry, that's how that is, like this. And onto this plate. This is onto the plate, like this. To get this out, to get this piece out, I went onto a carpet and just started hitting this down, hitting down, and then eventually this popped out. And as you see, I'm correct on the thing. These strips actually connect into these two wires there. So now I have to figure out how this actual mechanism works. Let me mark how this is going on. It's going that way to connectors, and then I could just take this off. It's going towards those connectors, right? So that means it was in here this way, and there it was in there that way. All right. So I got to figure out how this portion works. There's your diode that limits the direction of current. So this should be current passes positive this way. Is that how that was in there? Is the positive travels this way. Positive was the out one. All right. That's only letting current flow one direction. That's what the diode does. I'm not sure what the moving part is in here, but it's going to be down in the middle there. Does it pull this up? Does it pull this tighter or something? Is that the clicking? Oh, does it work like a magnet and clicks? Pulls this in? Because this is a piece of aluminum, I think. Let me find a magnet. Ugh. I think that's a piece of aluminum. Nope, I am wrong. That is not a piece of aluminum. Okay. That's a magnet. Huh. But maybe this does act like a magnet. But it still doesn't make any sense. What does this thing do? Because you hear it click. There's supposed to be a click. And you think that would click would be this coming up, even though there's no mark on here of a click. This was down in there, and I had to knock that out. All right, I'm gonna have to look at this more. Okay, so I noticed that this is actually metal. Where the hell's my damn magnets? This stem is actually metal. See? So I also notice it has nuts on there, and that's 5 millimeter. 5 millimeter. And this physically unscrews out of here. Held it with this. This unscrews out. So I'm kind of perplexed. I don't know what the coil does on this. It has to be a magnet. It has to work as a magnet. This is, I mean, this goes down in here. You got your rubber seal. And like you were saying. Alright. So I don't understand how this works. This is in here like this. At the bottom, that screw goes in there, touches that, and I tested it. That screw just screws all the way in. It doesn't physically touch this at all. So this is on here like this. So what does this electrical system do? If it worked as a magnet, I don't understand if this was a magnet, it would just pull up on this and tighten the area up to here. But I don't understand, because oh, does it tighten it and cut off the venting of this? I'd have to go look at my other video. But you know, I tested. I apply a voltage to this coil and it doesn't act like a magnet. It's like a dead short, but it comes up at 150 ohms. That's about what a coil is, I think. Unless this unless the diode is messed up for some reason. Damn. I don't understand how what this thing actually does. But I do know, since there's no moving part except for that, spraying fluid into here isn't going to do a damn thing to this. It isn't going to fix it. So spraying fluid into any part of this system isn't going to do anything. I don't know what hitting this with a hammer to get it to click again is actually moving or fixing. It doesn't make any sense. Alright, I got the replacement one on. And for some reason I didn't notice that there's a positive sitting right there telling you that's the positive terminal. Is that even showing up on the camera? Right there is a positive terminal. So anyhow, we have this on diode test. Usually diodes have to be tested outside the circuit. So anyway, let's diode test this new one. We get 33, 32, whatever that is. So let's diode test this one. .01. So I think the diode might be the problem here. I think the diode might be burnt out on this one. All right. So in reading up why there's even a diode on the coil, because if you understand how electronics goes, I'm pretty sure this energizes the coil and creates a magnet, and this magnet creates a magnet down here which pulls up on this and closes it off. I'm pretty sure that's how this is working. I'm gonna guess that mine was fine, and my small leak might have been because my tube that goes here is a little, the clamp that holds it on is broke, and I just noticed that now, and I have to use a wire tie to hold the tube on. All right, where was I going? Oh yeah, I was guessing that mine was probably fine, and like an idiot, I tested this with 12-volt battery, and I think I might have fried the diode. Although it doesn't stink. Usually when you fry a diode, it burns and whatever. But I think what happened is I fried the diode. All right, so anyway, back to where I was. If you understand how a coil works, you apply a voltage to it. Of course, a coil is going to be a dead short. Let's because it is a short, because it's just a coil of wire. However, it should have some resistance to it. We're showing like 2 ohms. 1 2 ohm. All right, let's check this one. All right, see this, it should be, this meter, I can't trust. Stupid Harbor Freight. Okay, 0 0, because it doesn't completely come on to 0. All right. So it should be like 32 ohms, and I think I checked this the other day, and it was coming up at 32 ohms. But I was also doing this, and the meter was showing 32 ohms. At least my other meter. That's why I changed meters. All right, so this one's working. So I was getting false readings, and I thought the coil was fine. All right, so back to, so a coil is a dead short, and as we see, it's going to have 30 ohms of resistance because of all the coiling, how the distance is on there. So if you understand how electronics works, you would say to yourself, why is there a diode on here? Because what a diode does is it limits the direction flow of current. And a coil doesn't care. You can put the voltage on here either direction, and it's going to do the same thing. It doesn't matter. So I read up on it. Why is there a diode on here? And the reason there's a diode on here is because what happens with a coil of this size, when you apply a voltage to this coil of 12 volts or whatever, and this is a switching coil, so you apply the voltage and then you turn it off. And when you apply the voltage, you're creating a big magnetic field. When you switch it off, that magnetic field collapses and causes a huge spike of voltage back out here. And what you have to do with relays, with coils, is you add a diode on there, and the diode works like a resistor. And that spike of voltage that comes out, it grabs it and clamps it and gets rid of it. Because if I go cut this off and go put this on the car and let it click it on and off, that spike voltage can come back down and fry my PCM. So that's why you have this diode on here. All right, so why do I think this diode is short? Because I just checked that and it said zero ohms, which I think I burned out the diode. Burning out the diode now makes a dead short across this because the diode is in parallel with the coil. So if I do a dead short here, you're skipping the whole coil. You're skipping the whole coil. So in theory, I should be able to disconnect this diode here and then apply a voltage, and it should pick this up and act as a magnet. I'm too scared to apply a voltage. I don't want to burn it, but I think you could test it with 5 volts. Make sure you're getting the positive on here. But if I take this diode off and apply a voltage, it should pick this up if my theory is right, because the only thing that this possibly can be doing is working as a magnet. And then, once I get this diode off, we can see how to fix it. So pretty much I've shown you how to fix this thing. But first I got to take this diode off, and we'll got to see if this diode is actually bad. And this thing goes back to working like a magnet and picks this up. And that is also why, because I was connecting 12 volts up to this, and as soon as I was touching it, my connectors were getting red hot. That would instantly burn these. So the amperage that I was applying to that can't be going over the coil. It has to be a dead short over the diode. And once I get that diode off, I'll be able to read those numbers and see what exactly this diode is. So there you have it. The thing with this is I thought it was crimped on there, but this is actually welded on. It's not soldered on. It's like a hot metal weld onto there. See, it's like pressed on. I don't know if they did that before. They must have did that before they connected up the wires, because that would have been hot enough to melt those off. Oops, I'm not on there. All right, let's back out. All right. So I'm going to try to disconnect that diode and see if I can make this into a magnet. All right. I have the diode disconnected. And let's now check the ohms. They should be around 35. There you go. And for those people that don't understand how electricity works, you connect up to a coil, it doesn't matter. 35 ohms, 34 ohms. So now I have this diode disconnected. I could actually do a proper test. And a diode, it flows. The electricity flows towards the positive area. So in theory, you should be able to go this way with it. And it's coming up as 0 like a short. Zero like a short. And then we could also test the diode for ohms. I believe it should show nothing or very high in one direction. A short. Short. So this diode is bad. So now I got to find a voltage source that's not going to fry the coil and see if this turns into a magnet to pick that up. All right, so I got a 18650 battery. It's about 4 volts. And can you see it? Watch what happens when we give it the juice. See that? So this coil, in fact, is turning into a magnet. See that? So the diode is bad on this. And I think I burned the diode out. So I think my sensor was fine this whole time. And I burned that out somehow. So that's how this works. It's a magnet. There's no... I mean, I can't say there's no moving parts. I mean, this is the actual moving part. And it's on that spring. Like this. I mean, this did have some carbon on it. And it gets sucked up to there. I wish I had taken this apart before I threw that stuff in there. But as we showed, what could be sticking is this. If you don't hear it clicking, you want to test your resistance. If your resistance comes up to near 0, that means your diode is a dead short. And you could take this apart and replace that diode. As for the blow test, this was the other thing that goes on with these. This is rubber. That's what cuts off this seal here. I don't see that getting carboned up. Oh, I guess someone said it can get dusty. I do see some dust in there. So again, you're not going to want to put fluid in there. Just take the thing apart and clean it. It's saying it could get dusty and it doesn't seal up good. I mean, that's possible, but this thing I could tell is not worn. I checked blowing into these. You can blow into this one and it comes out this one. And you see that there's an arrow there showing you that's the intake. And the same thing happens on this one. You blow on this one, it comes out that one. And then when you look at this, I mean, that's how it should work. Let's see what happens. You should be able to push this in there and close that off. All right, so I see another thing. You're blowing in here, and was it coming out there? Let me test that. All right. So you blow in here and it comes out there. Now I'm blowing in this one and it's coming right out there. The only way to stop that is, let's see, with the spring on there. When you put the spring on here, can I do it? All right, when I have the spring on there, it's not coming out here. It's leaking out these edges here. So another possible thing is getting carbon into these edges here, which again, just take it apart and clean it. Because just sticking fluid down in there isn't going to help you at all. You have to physically take this apart and clean that, if that's the issue. And like I showed, this thing just clamps right back together. All right, GP. Is that 10? 10G dash 14.7. And the other thing is flower symbol 0. Three 0 8A. All right, so that diode is a GP10G. I think this is the proper one, a 400 volt, because apparently what happens is when you cut the current to that coil, the voltage flips and tries to come backward at a max of 10 times the voltage. So if you have 14 volts on this, it's going to flip backwards at 140 volts. So you want this diode to be able to handle 140 volts and not let it pass back through. So the diode only lets electricity flow in one direction. So when you cut the power, it flips and sends 140 volts max back the other way, but the diode is going to say no, that's not happening here. It's saying not up in here, brah, and dissipates what's going on. I think that's right. I'm going to have to read into this. So it's going to come back the opposite way. And how does the diode stop that from doing it? Because it's in parallel. All right, this is in the unit this way. So this is in the unit this way. This is the positive. All right, yeah, so this is the positive. So positive comes in and it won't flow in this direction. All right, I see how it is. Yeah, 400 volt, definitely it. Definitely it. So when you energize this coil, your positive is on this side. And if you see, a diode only lets electricity flow this way, towards the white line. So when you apply a positive voltage to this, it doesn't go through the diode. So when you cut power, the 140 volts tries to go in this direction, and the diode is like, yeah, give me that, boy. It's like, take it, give me that. And it's basically a dead short. When the power goes in the opposite direction, it's a dead short into the diode and kills it and doesn't let it come out and attack you. So it's not the other thing I was saying. It's like, yeah, give me that shit. Yeah, baby. All right, so that diode is gonna work. You just need a diode that's going to exceed the voltage of the car, which is 14 or more volts. Well, you want to exceed. You want to go over 20 volts because you don't know what's going to spike out of the alternator. Because when you exceed the voltage in this direction, it jumps the diode. That's why you don't want to go higher than what the diode's rated for. So that one I was showing you, that 10, whatever that was, the GP10G 400 volt, that will work in this. It's going to say no to the 12 coming this way, and then when you cut the current, it's going to say, yeah, baby, give me that 130 volts. Give me that, son. And this is a 1 ampere, so it's going to be able to handle 1 amp. And I don't think the current is an issue. You're not going to get over 1 amp up through this coil because it would just fry these leads. It's about the voltage. So yeah, I think I'm going to order one of those for $2.30. Oh, $6 shipping and handling. I think there's some, so that's going to be $8.30. I think there's some on Amazon for not cheaper, but these are probably coming out of China. Yeah, whatever. So you want I think it's the voltage and the current you want to worry about with a diode. You might be able to use any diode as long as it's got a higher voltage and can handle 1 amp. All right, so I have a whole ton of circuit boards. I have tons of diodes, so I'm not gonna buy that. I'm gonna take a diode off something else. I have tons of electronics somewhere. Take it off a burnt board. Okay, so I'm trying to think something out. When I first started this video, this did have build up on it. You still see something's in the middle. That had some on there. I wish I had opened this before dumping fluid down in through it. I had dumped fluid down in there. Well, actually, dumping the fluid down wouldn't have got down to this area because of the O-ring. I dumped fluid down into this area, which wouldn't have gotten into that bottom area either. Huh. So there was no way for fluid to get into this bottom area. I know damn well no fluid got into the bottom. Well, I don't know damn well, do I? How would a fluid... There was no way for fluid to get into this bottom area because it wasn't going to get by this seal. In order to get into that area, you would have to put fluid into here, which is going to backfill this side. Yeah, the only way you're going to get something down into this, because this is the part that's going to stick on this at least, is you're going to have to put fluid into this area or down, down this tube. You'd have to spray down this tube to get fluid down there. And I guess when I did fill it up, it's possible I did spray some down in there. So anyway, I'm thinking that I may have been having problems with this. It may have been sticking. But that wasn't going to cause a vacuum leak, a small leak. Because if this sticking up and closing that off, that's going to not let it... That's not gonna let it vent. And I'm trying to think this out because about 2 years ago I did have the strangest thing happen to my car. After filling up the tank with gas, the car would not start. I had to keep trying, and then it tried to start and it faltered, and it stalled. And then I did it again, and just before the battery was gonna die from trying to start so much, it caught. And it started faltering, and then it was okay. And I haven't had that issue since. And one of the symptoms of this failing is that symptom I had. Because what happens is when you go fill your tank, all those vapors come up and through here, and they go into here and into your intake. And just flood the whole, and into your pistons, and just flood the whole system. So it's like having a flooded system, and the car won't start. And when it does start, it shudders and shudders like it's flooded, because that's what happened. It's flooded with vapors. So this thing did fail like that about 2 years ago. That was. But beyond that, I've never had that issue again. So I'm just thinking maybe this thing is a little dirty somehow. I mean, I do see some dust down in there, but I don't know. So the vapors would be coming in through here. They can't get by this. They can't get to the other side of this. The vacuum sucks here. I don't remember how that works because I just said it would have to come through here to get into the intake. That's not how that works. Oh, that's right. It comes in here, and this tube goes over to the no. Let's see. How is this? This is mounted. This is mounted like this. This is my tube that's fallen off. This one. All right. Yeah. So it's this one. This one goes to the intake. So yes, if this isn't closing properly, all the vapors come in as you're filling your gas tank, and they go right into the intake and totally flood out the engine. And that's another symptom of this failing. So that would show a sign of this failing here. And you do see that's dirty, really dirty. So that would make it not close good. And I keep screwing with it throughout the whole video. You want to look for cracks or anything. But I only had that issue once. And then the small leak. Which, maybe it was this. It wasn't this sticking. That's not it. It's because this is the thing that your vapors come in and then out here to your intake. Into your manifold. Intake manifold. So I guess dumping fluid down in here might clean that. But as you see, it didn't clean it all that well because there's all dust and stuff still in there, and this was still dirty. I don't know. I don't know how I'm going to post this video because at the start I said nothing's going to happen putting fluid down in here. When it is going to happen, it's going to clean this. I don't know. I'll just call myself an idiot and say jump to whatever portion, or I'll put this first. So, yeah, there you go. All right, let's see if we can get any. What we find in this hole. And as you see, that's going to be pretty hard to clean. There's that. Let's see what we get. It'll be hard to clean that way because you have this in that hole, and it's being pushed into that hole by this spring. So you're not going to be able to clean that well by putting fluid down here. And if you put the wrong fluid, you're going to make this rubber shrink and make everything worse. If you do something like something that's got the chlorine in it, it's just going to eat this rubber and destroy it. But you're going to want to clean this area here. Clean in there. You want to clean out everything in here so it's able to seal down. So this rubber can seal down into this crack. There shouldn't be anything in this anyway. because this thing has been pressed in there all its life. But make sure none of this external dirt falls into there if you take this apart. And this hole, obviously, the hole is just way too big. How is that? Oh, that hole is shut off. What's that, like a piece of metal in there? How the hell is that piece of metal in there? That's weird. Why is there a piece of metal in there? How the hell did it get down there? That's weird. Why would they put a piece of metal in there? Looks like it's kind of threaded. It's really weird. I wonder if different cars, they want that to be smaller, so they jam a piece of metal in there. I don't even know how you get that metal in there. If you take these off, make sure these things don't fall off, because these things come off, see? All right. So I just wanted to see on camera what happens if you clean that hole. And I need to get, I'll replace this diode. I'm not gonna, this video will be up before I replace that diode. I'm not gonna do that. No need to put that on video. We already proved that that diode is bad. All right, there you go, buddy. All right, so you can take this back port off. Before you do that, make sure you mark where it's connected, in. So each of these tabs have an opening in the back. See the opening? So you could stick a screwdriver in there and pry them. First I had to put another screwdriver in there to hold it. When I pried open this one, I put a screwdriver in there to hold that one, because if you go try to unclip another one, this one jumps back in. So once you get two of them unclipped, like opposing, then you can just go all the way around, and then one of them is going to stay stuck. And you just got to pull a little and wiggle it, and eventually it'll just pop off. Oops. Did not want that to happen. That just jumped out of my hand. Okay. So that opens up. And I don't exactly know how this portion works right here. I just know I apply a voltage and it just shorts. So I'm pretty sure this is stuck. I'm not sure how that does this. Does it? Nothing on this rotates. I'm not sure how this actually works. Oh, okay. This one blows down at the hair. This one blows to here. All right. So this doesn't appear to be dirty. And we got a pin right there. All right, so that pin, we got a pin there. That pin is going to close that off. So putting any kind of fluid down into here isn't really going to do anything for you. Because this is what shuts off that valve. So I guess there's some sort of spring that pushes on this. I'm not sure how this spring technique works. That's going to push on that and close it. But how does the spring release tension? I don't understand how this works. I don't know what this motor is doing. I do see the hole in there. I do see that. I guess if a vacuum, because this is going to be a vacuum, that's going to suck air, and sucking air is going to pull on this to open up this valve. So I don't see how this portion works. I know if I apply a voltage, it's like a dead short or whatever, even though it comes up at 30 ohms or 100 ohms or something like that. If the vacuum pulls on this, pulls it, I guess opens that up. Oh, I'm going to put this back together. I don't see how the electrical part works. I mean, what is it actually doing? Oh, I see what it does. This opens and then it vents. You have a vacuum. The vacuum comes here. The vacuum comes here, pulls on this to open it up. To open up that valve. All right. So I think this might be old, because when this is in the normal state with the spring, I could still blow on that. So this is a vacuum from your vacuum, and it sucks on this and pulls this up to open up the line. This, when this relay kicks in, it vents the vacuum out here and through here, so it's not a dead short making a noise. This muffles the noise, and that stops this from being pulled in. That's how that works. But right now, mine's not doing shit. So what you want to happen, you want to be able to blow into here. When this thing's engaged, you should be able to blow into here and it'll come out up there. Not in here. See, I can't blow in that. Yeah, that seems like it's stuck or something. Maybe the fluid has to go into here to clean it. Because I blow, and then I stop it, and then I can't blow anymore. Alright, so I'm going to look into that. Okay, so if you're going to have any chance to clean this, it's most likely going to be putting a rust eater down in here, because the moving part is going to be between that coil that's way down in there. There's probably a valve that's moving down in there, and it's rusted. But you're pretty much not going to clean this. I filled it with liquid wrench, and I'll do it again, and I'm like hitting this, and it seems like a valve is moving. It seems like something is moving now that I filled it with liquid wrench. I had it filled with liquid wrench for quite a while. And you see down into that tube, somewhere down in there is the valve that's going to move and open up to here, so it stops sucking on this diaphragm. And again, like I said, throwing liquid down into these holes isn't going to do a damn thing, because it's the diaphragm. It's this diaphragm's rubber pin that sits in here, and that doesn't get dirty. So when you put fluid in there, you're not doing anything. You're accomplishing nothing. It's this back area. See, this is totally sealed, and that's going directly to here until whatever's down in here moves down in there. Now, I suspect that that's all rotted down in there that we can't see. I have no idea how to get that out, how to get this straight out, because those pins are stopping from getting out. I mean, I know that metal plate right there is stopping it from coming out, but so are these metal fins. So I don't see how to get that out of here. Usually there's a way to open things, but this doesn't look like it. Looks like it got sealed this way. But down deep in there there's a coil, and that coil is going to energize and pull at something. So there's probably inside that coil, there's probably a metal bar that's going to get moved. I'm going to have to buy a new one of these, and when I do, I'll cut this open and see what the hell is in there, because mine's definitely not working. I get you know, low leak, this tiny leak, and with a Ford I could stop it from ever recording it by never letting the car get below half a tank, because on my particular car, the 2003 Crown Vic, the only time it's going to test this system is when you get below half tank and then fill back up. If you never get it below half tank, it'll never run the test on it. So if you need to go to emissions, just keep this, just reset it, and just drive the car, and never let the fuel get below half tank for the first, you know, like 500 miles or whatever, a couple of days driving, and then go up to emissions. And they're not going to fail you for this test not being run, because you can't force this test to run on the Ford that I'm aware of. Well, at least they're not going to force it. So that's how I go through emissions. I don't let it, because who cares about a low vacuum leak? Doesn't mean anything. Alright, so I'm going to have to get a new one. I'm going to put some more liquid wrenches in there and try to free that up. It actually sounds like it's free now, but we'll see. Alright, a thing to note, I got this full of liquid wrench right now, all the way up past the thing. If you do this, oh shit, well, that was stupid, now it's all over me. If you do this, when you go to take out the liquid wrench, make sure you get that all out of there, and then spray this with brake cleaner or carb cleaner to get all that out of there. Make sure to get the carb cleaner or the brake cleaner, I prefer carb cleaner, to get that out of there, because carb cleaner will dry up. Because you don't want this wet with this liquid when you put it back in the car, because if that coil gets hot, it'll ignite. And, you know, this thing's going to catch on fire. So you want that, you want all the, you want this sealant out of there. You want everything dry in there. You don't want any flammable shit in there. Did I fuck up my shirt? God damn it. Ugh. Alright. I don't expect this to work, but whatever. It wasn't working in the first place, so here they're $40 to $60 to replace them for this car. Oh, into the bucket. You stepping on it now? You done throwing it?
Yeah.
Throwing a pie? Whoa! You fell down. That was way too high. Oh no. What are you in a rap movie? Got your pants on?
Yeah.
You gotta pull up your pants.
Hi everyone. Today I'm going to teach you how to use slime decorating with stuff. So I made, as you can see, I made this one with this, and then I just did. So as you see, this is plain right now, just has sparkles in it. And now I'm going to put the stuff I want to put in it. So put these in. You could put these in. Put these in. Put these in. And then you want to mix it. Okay, there you go. And then you put my sparkles in. Open this, I'll hold it.
It's done.
No, it's not.
Close it out.
As you can see, this is how you make the slime
Keep it over
catcher.
the table.
Catchers. Thank you. Peace out.